Hey everybody, so in this video we are going to determine which of the following functions are models of exponential growth and exponential decay. So real quick, you have growth anytime your growth factor here, so this number in the parentheses, is larger than 1. So remember, if we looked at this as an equation, this would be y equals a times b to the x. So anytime b is greater than 1, we're going to have growth, and anytime b is smaller than 1 but greater than 0, we're going to have decay. So that's something we want to jot down and keep in mind because we're going to be using that for these 9 examples. So on number 1, 7a, it says determine whether I have growth or decay. Well, my growth factor here is larger than 1, so I'm going to have growth. On B, my growth factor here is 0.92. That's smaller than 1, so I'll have decay. In C, my growth factor is 3/5. 3/5 is smaller than 1, so this will also be decay. On D, you may be thinking, oh, that's a fraction, it has to be decay. But that's not true because 7/5 is greater than 1. So this means that I'll have exponential growth in this example. If you've never seen E before, E is approximately 2.71828. So this is Euler's number. So here, since it is larger than 1, we're going to have exponential growth. Now on F, we have 2 raised to the negative x. Well, you have to evaluate exponents first. Remember, if I had x to the negative 1, this is the same thing as 1 over x. So 2 raised to the negative x is going to be the same thing as 9 times 1/2 raised to the positive x. Remember, the negative exponent means that number has to flip. So since my growth factor is 1/2, this is going to be exponential decay. On G, my growth factor is 3, so this is growth. On H, I have e to the negative x, so if I rewrote this, this would be 1 over e to the positive x plus 3. So that's going to make this decay. And then lastly on I, the negative x means that the fraction must flip, so this would be 230 times 5/2 all raised to the x. So 5/2 is greater than 1, so this would be exponential growth. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video. A special thank you to Matthew Winking. Matthew is the author and the sole contributor to the PDFs used in this video. If you would like access to these PDFs, please visit Matt's website at mattsmathlab.com.